Greetings everyone, my name is Mark. I'm a high school student and I'm aspiring to become a quant. I'm very passionate about math and finance. I'm mostly recording these videos for myself to either come back to them later, and plus I'm recording them to deepen my understanding of math and other important topics. And while I'm already recording them, I might as well share them and someone might find them useful. The reason why I'm trying to explain this or to teach this is because that if you explain or teach something, you remember about 90% of the things that you say, whereas if you only read your notes and go through them, you remember only about 5% of the things that you've actually written down, that you've read, to be precise. So I hope that at least someone will find this useful, and I'll be going over multiple topics from simple mathematics to complex quantitative methods, and today we'll be looking at sets. And sets are essentially um, a cluster or a group of any element or of any elements which have a common trait or that have something in common, which are then visualized in certain sets, usually in circles. For example, right here we have set A and set B. These can be sets of objects, of a set of numbers, a set of ideas, or of anything else. And some sets can belong to other sets, and these are called subsets. For example, A is the subset of B, and we use this symbol right here, which tells that A belongs to B, which means that all the elements of A belong to B, but not all the elements of B belong to A. If all the elements of B belong to A, then this would be true. Oops. And if B were equal to A, then all the elements of B would belong to A, and all the elements of A would simultaneously belong to B. And if you have two sets which only have some elements in common or overlap each other, then you get something that looks like this. It's called a Venn diagram, and it shows certain sets which have certain elements in common, which belong to both sets essentially. So there are multiple variations. So the first one is when we have all the elements which belong to A and B. This is called the union of A and B. This right here is the symbol that we use to demonstrate that. So this is the union of A and B. If we want solely the elements for, let's say, A, then that would be the union of A and B, which are all the sets, or sorry, not all the sets, all the elements which are in the set, minus B. Of course, this applies also for A, if it were, the opposite way around. The third variation is if we only have the intersection of A and B, which are only the elements which belong to both A and B. And this is represented as A intersection of B, which is essentially this symbol that we had before, but it's upside down. And then the fourth variation are the elements that belong exclusively to A and the elements that belong exclusively to B. So essentially it's all the elements except for the ones that belong to A and to B. The word and is very important because that means that they belong to both sets. So if we were to look at the fourth variation a little bit closer, we can calculate the union of A and B as the sum of set A and set B minus the intersection of A and B. So essentially, we would be taking the union, which is this, and that's equal to B or A, doesn't matter, plus A and B. Oops, sorry for my drawing. And if you had that, well, you'd still have the intersection, which is left, so you have to subtract that. So here's an example. So we can draw our Venn diagram just like so. Set A and set B. Set A contains 10 elements. Sorry, I guess I should read the problem first. Set A contains 10 elements. How many elements does set B have if there are 2 elements which belong to A and B and 16 elements belong to A or B? The words or and are very important in these cases, and I'll explain why soon. So, but if we go from the start, set A contains 10 elements, and we're trying to figure out how many elements does set B have. I'll just put a question mark here, or X or Y or whatever you want. If there are 2 elements which belong to A and B, which means that there are 2 elements which both of these sets share. The word and is very important in this case. That indicates that they belong to both. And 16 elements belong to A or B. So there are 16 elements, and they belong either to one set or the other. And we don't know exactly how many belong to which one. So what I like to do is that I like to draw a box around my Venn diagram, and just here in the top left corner write 16. And by that everyone knows that there are 16 elements in this set, but we don't know exactly where they are. But we do know that there is 16 of them. So according to our equation right here, which by the way we can, put some things to the other side and, move around with it and figure out certain things. So we can figure out how to calculate for B, which is what we're interested in at the moment. That's what we're trying to solve. So we can subtract A from both sides and add the intersection of A and B. So after doing that, we'd get the union of A and B minus A plus the intersection of A and B is equal to B. For those who are interested, the reason why there are these lines here is because these are actually the cardinalities of either A or the union or the intersection of A and B, but that's not really that important. So yeah, just for those who want to know. So with the help of this, we can calculate how many elements are exclusively belonging to B. So that's the union minus A plus the intersection. So our union is 16 because there are 16 elements, minus A, which is 10, and plus our intersection, which is 2, and that equals to B. And after this, 16 minus 10 is 6, plus 2 is 8. B is equal to 8. So there are 8 elements which belong to set B. Here's also a practice problem for those who are interested. That'll be everything for today. Thanks for listening, and enjoy the rest of your day, and stay safe.